Hello, everybody, and welcome to my class. Today, we're going to be studying Algebra 2, and this is in the 7th grade curriculum. Okay, let's begin class. So this is our schedule for today. First, we'll do a review of last class. There's still some newcomers, so maybe you haven't been to last class, and I'll review some of the material from last class. And then, secondly, we'll be doing some more advanced single variable linear equations. Then lastly, we will be solving advanced literal equations. Okay, so let's first start off with a review. So remember last class, we studied single variable linear equations, identity equations, no solution equations, and lastly, rearranging multivariable equations. So let's review the definition of a variable in a linear equation. So the definition of a variable is a symbol that denotes an unknown number. Let's say it could be x, right? Or y, or even a star, or even a heart. Okay? It could be any symbol, but it has to denote an unknown number. And then the definition of a linear equation is an equation containing variables, numerals, and an equal sign. So let's look at some examples of linear equations. Okay, so let me come up with one. Let's say 2x plus 3 equals 4. Okay, so this is an example of a linear equation. Does it contain variables? Yes, it does contain x. Does it contain numerals? Yes. This is 2, 3, and a 4. So, check on that. And then, does it contain an equal sign? Here's our equal sign. Check. There we go. That is a linear equation. And then, let me come up with a more complicated one. Let's say we have 3 times the quantity of 3x plus 4 equals 26, or 5x minus 1. Okay? Let's see. Does it have a variable? Yes. There's the x right here. And then, does it have numerals? Yes. A lot of numerals all over the place, right? And lastly, does it have an equal sign? Yes. Right here, right? So this also qualifies as a linear equation. So now let's start off with a warm-up exercise that I do commonly. Okay, so the warm-up exercise is please come up with some examples of linear equations. Please come up with your own examples of linear equations. Okay? Steven says x plus 1 equals 2. Very good. Then Jasmine says y equals 2x plus 5. Very good, very good. Then Rui Shen says 3 times the quantity of 4x minus 3 equals 3 plus 2 plus 6x. And then the next one how do I pronounce your name? Okay. Someone, let's just say someone came up with x plus 2y and equals 3 plus z. I don't want to offend anyone by saying their name wrong. And then Stephen also says x equals 1 plus 1. And then Kiki says 999,999x plus 88 equals some very big number that I'm not going to say. So there are a lot of examples as you guys have come up with. So those are very good examples. Okay, and there are like infinite possibilities. Okay. So let's move on. Let's learn how to solve a linear equation. Okay. So now you know what qualifies to be a linear equation. So now let's see how to solve a linear equation. Let me change my color real quick. There we go. And then let me come up with an example. Okay. 5x plus 4 equals, let's say 4x. And then minus 4. Okay. So 5x plus 4 equals 4x minus 4. This is an example of a linear equation. So now I'm going to show you how to solve some of these. So you need to use what is called inverse operation. Okay, so I'm going to write it down, and you might want to take notes on this. Inverse operations. Let's say we have addition. Inverse means like the opposite. Okay, so the opposite of addition is subtraction, right? And then we have multiplication. Opposite of multiplication is division, right? And we're gonna use only these 4 symbols today. Okay. So we need to isolate x on one side and then all the other numerals on the other side, right? So that's the main goal. We need to isolate x on one side and everything else, and put everything else on the other side. So let's say we want to move all of the x's to the left-hand side right here, and then we need to move all the numerals to the right-hand side. Okay, so let's first start with moving 4x to where 5x is. So let's do that. And then the next stage, after we simplify, would be x plus 4 equals negative 4. Now why, when we combine 5x and 4x, why do we not get 9x? I mean, 5 plus 4 is 9, right? But remember, we need to use inverse operations. Instead of adding 4x, we need to subtract 4x. Now, why do we need to use inverse operations? Well, to move 4x to the left-hand side, we need to subtract 4x from the right-hand side and we need to cancel out 4x on the left-hand side, right? We need to just cancel it out. So to cancel out 4x, we need to obviously subtract 4x, right? On the left-hand side, right-hand side. And then to keep it equal, we need to subtract 4x on the left-hand side too. So that is how we use inverse operations to simplify this equation. And then the same is with the next stage. We need to subtract 4 from both sides. And once we do that, these two 4s are canceled out, and we only get this numeral over here. So when we simplify, we get -8. X equals -8. So did everybody get that? Okay. Very good. Jasmine, Stephen, and Ray Shen. They all got it correct. Very good. And so I know a lot of you already know this. So let's start with some review problems. Okay, and we'll speed through these. And then once we're done with these, we'll start doing some other problems. Okay, more advanced problems. So the first review problem is very similar to the example that we just solved. Okay, so the first problem is 4x plus 10 equals x minus 5. Okay, let me repeat. 4x plus 10 equals x minus 5. So please put your answer in the chat box. And then after a few moments, I'll go and check the answers. So during the meantime, I will leave this slide open for you. And then please put your answer in the chat box, okay? So I'll give you a few moments to try and solve this. Okay. So we have a few answers. Jasmine says x equals -5. Stephen also says the same. Kiki says the same. Thomas says x equals 5/3. And then Ray Shan says x equals -5. And then Frank says x equals -5. Stephen says x equals -5. So there's a lot of more answers. They're about all the same. So let me walk you through this, okay? So you probably already know it, but let's review, okay? And then remember where I said we need to isolate x on one side, right? So let's put x on the left-hand side, and then all the numerals on the right-hand side. So let's move those two. So we need to subtract x from both sides when we're doing this. And the next stage should be 3x plus 10 equals -5, right? We put 3x on the left-hand side. Now we just need to remove 10 from the left-hand side and put it on the right-hand side. And how do we do that? We subtract 10 from both sides, right? And the next stage should be 3x equals -15. And then, remember, we have this 3x, right? We have 3x. And to get x by itself, we need to divide by 3, okay? Not divide by x. Sorry, that was a mistake. Divide by 3, okay, on both sides. And then 3x divided by 3, you get to cancel out the 3. Then you get x equals -15 divided by 3, and then simplify it, and that is -5, okay? So does everybody understand where I get that answer. Does everybody understand? Yes or no? Yes. And Carney asked if the variable on the left-hand side is the traditional way. Yes. Mostly it is on the left-hand side, and it's the traditional way or standard way. Okay. So here we have another problem. Number 2 is 3t divided by 4 equals 3 plus t. Okay? So 3t divided by 4 equals 3 plus t. Now, we're dealing with a fraction here, right? We're dealing with a fraction here. So can anyone figure out the way to deal with this fraction? So please put your answers in the chat box. Then I'll check. Okay? So please put your answers in the chat box. And once you start doing more linear equations like this, you'll get faster and more accurate. Okay? So Jasmine says t equals -12, and Stephen, Rishan, and Eric, they all agree. So any more answers? Any more answers? Carney, you haven't answered yet. So I'm pretty sure you're still working. So please, everyone, please submit the answer in the chat box. Okay. So okay, we have a few answers, and then let's wait for more answers. Okay. Does anyone have more? Okay, Ethan says t equals -12. Very good. Let me walk you through how to get that now. Okay. So remember, last class I told you to get rid of fractions. Remember fractions, this fraction right here, 3t is dividing 4, right? 3t is being divided by 4. And remember, the inverse operation of division is multiplication. So to cancel out this 4, you have to multiply by 4, right? Then you cancel out, right? But not so fast. Remember, this is an algebraic equation. Right? You have to keep it equal. So every term has to be multiplied by 4 in order to cancel out the fraction. So now, let's move on to the next stage. So we have our fraction canceled out. We have 3t. And then on the right-hand side, we have 3 times 4, which is 12, plus 4 times t, which equals 4t. Okay, so now let's move 4t to the left-hand side. So we get -t equals 12. And remember, we have to get t by itself, not negative t. So let's divide each term by -1. And then what we get is t equals -12. Okay? Very simple. Now, let's move on to the next review problem. In this problem, we talk about distributive property. Okay? Remember to multiply every term inside the parentheses by the number right outside of the parentheses, okay? So please solve this problem. I'll give you a few moments and put it in the chat box when you're done. Okay. Jasmine says no solution. And then Frank also says no solution, and Eric says no solution. Okay. So let me go back to the PDF. And then here's the question. So I'll give you a few more minutes to sort this problem out. Some students said no solution, and then some students haven't answered yet. So please put your answer in the chat box. Okay. Ray Shan says no solution. Okay. Then I'll walk you through this. So remember this derivative property. We have to multiply both 3 and x by 4, right? Right here. So 4 times 3, 12. 4 times x, or x, equals 12 plus and another set of parentheses, okay? So let's just multiply 2x by 2, which is 4x, and then 2 by 1, okay? And there we go. And now you might notice that we have a 4x on both sides, right? A 4x on both sides. And what you can do is subtract 4x from both sides. What do you get? You cancel 4x out, right? You don't have an x anymore. And then this is pretty strange, right? The end result you get is 12 equals 14. Now that can't possibly be true, right? That is a false statement. Okay? And remember last class I said all no solution equations end in a false statement. Okay, so this is a false statement. This can't be true. So this is a no solution equation, okay? This is a no solution equation. So everybody who got no solution, congratulations. And then we have our last review problem, and this is rearranging multivariable equations, okay? So please solve this one, and solve for x, okay? And then there's some newcomers. So for the newcomers, like Thomas, if you don't know how to solve this, I'll walk you through it once the others have answered. But the other students, those who have been to last class, you should know how to solve this. And I'll give you a hint. This involves factoring. Okay, so please put your answer in the chat box. Okay. So Jasmine says x equals 4 minus f divided by a plus c. Okay, very good. So this is our problem. I'll give you a few more minutes. Moments. Few more moments. I can't afford you to give you a few more minutes. Okay. We're already running pretty late on the schedule, so we need to speed this up. Okay. Okay. So x equals 4 minus f divided by a plus c. So we have three answers containing that. Okay, so let's solve this one. Okay, so look, ax and cx. Remember, we have to solve for x, right? We want to isolate x on one side, and then all the other numerals and variables on the other side, right? That's how you solve a multivariable equation, right? That is the main goal when solving the single variable equation as well as a multivariable equation. But how do you separate x from ax and cx? Look, they both have a common factor, right? X is in both ax and cx. And then we can factor it out. X times a plus c. And this is called factoring. Okay? This is basically doing the opposite of the distributive property. In the distributive property, we're unwrapping the parentheses, right? But now we're like putting the parentheses around the variables. Okay, so this is the reverse distributive property, you could say. And then this would be our next stage, right? We need to isolate x. And to isolate x, you can just divide both sides by the whole thing. You can just divide both sides by a plus c, right? And then you get this. X equals 4 minus f divided by a plus c. So a lot of you got that answer, so congratulations. Very good. Okay. So now let's start working on a new topic. Let's start working on more advanced linear equations. Look, so we have two different fractions right now. We have two different fractions. Usually we only have one, right? We started solving simple linear equations, but now we have two fractions. So these problems are a bit more advanced, and so you might have a harder time to solve them, but we will be using the same concepts, okay? So please try your best to solve this first problem, and if you don't know, I'll walk you through it later, okay? So please put your answer in the chat box. I'll give you a few moments to try and solve this one. Okay. Stephen and Jasmine says y equals 6. And then Eric agrees. Okay. Any more answers? Okay. And Ethan also says y equals 6. Okay. Very good. Very fast. Okay. I'll go back to the slide, and then you guys can have a bit more time to work on it. Okay. So Thomas says y equals 34 divided by 3. Kiki says x equals 17 divided by 7. And then Ray Shan says y equals 18 divided by 7. And then there are no more answers. So let me walk you through this now. Also, Michael rose his hand. So Michael, what do we need? So if you have a question, Michael, you can put it in the chat. Okay? So Michael, what kind of question do you have? Okay. Well then, now we'll start solving this problem. So our variable is y, right? And we need to isolate y on one side, but we have these kind of fractions, and we have to separate y from all these numerals, right? And we have two different fractions. 2y is divided by 3, and y minus 4 is divided by 2. Well, if it were 2y divided by 3 plus y minus 4 divided by 3, we could just multiply by 3 on every term, right? But you can't do that because these objects are being divided by different numbers. And when we have that, we need to multiply by the least common multiple. Okay? We have to multiply by the least common multiple. And what is the least common multiple of 3 and 2? Well, it is 3 times 2. And then that equals 6, right? So that is the least common multiple of 3 and 2. So let's multiply every term by 6. So 2y divided by 3 times 6 plus y minus 4 divided by 2 times 6. And then we have 5 times 6. And then, so let's simplify this. We have 4y, okay, first term right here. And then we have 3 times the quantity of y minus 4, okay? And then that equals 30. Then the next stage, we need to unwrap these parentheses. Okay, next stage, let's simplify. So last we get y equals 42 divided by 7. Okay. So and then, yes, I forgot to simplify this one. 42 divided by 7 should equal 6. So a lot of you got 6. So very good, very good. Congratulations. This was a pretty complicated problem compared to the ones that we did before. So very good job. Okay. So now let's move on. So this is our next problem. This also involves a bit of distributive property and a bit of fractions, okay? So this shouldn't be too difficult. This is pretty similar to our last problem. So please try and solve this. Okay. And also put your answers in the chat box. Okay. Steven says impossible, which is probably no solution. And Jasmine says no solution. Okay, I'll give you a few more moments to try and solve this. So those who have not answered, please submit an answer. And then, so keep working if you haven't finished. Okay, I'll give you a few moments of time. Okay. Ethan says no solution, and Eric also says no solution. So a lot of people have said no solution. Okay, so let's solve this now. So first, let's unwrap the parentheses. Okay, so multiply every term inside the parentheses by 13, right? So we get 13 divided by 3x plus 26 equals, we have a 26 over 6 right here, right? And this is an unsimplified fraction. So let's try to simplify it. Okay, so let's simplify. We just divide both 26 and 6 by 2. So we get 13 over 3x plus 7. And then you realize something very miraculous, right? What do we get? 13 over 3x on both sides. And then you can just cancel out. And what are you left with? 2 terms. And they're both numerals. And then you get 26 equals 7. Now, I said before, right? A no solution equation always ends in a false statement. So this is a no solution equation. Okay, so this is no solution. So a lot of you said no solution. Very good. Let's move on. Now we have our third problem. Okay, so this is our third problem. 3 over x plus 1 equals 4 over x plus 2. Please try to solve this problem. Okay? Please try and solve this problem. Also, put your answer in the chat box when you're done. Okay, so Jasmine says x equals 2 on this one. Okay? Kai Xi also says x equals 2. And then Ethan says x equals negative 2. Eric says x equals 2. And then who else? Okay, I'll give you a few more moments to try to solve this equation. And there's a way to simplify this equation. And once you simplify it, it'll be really easy to solve. So please try and find a way to solve this equation. Okay, now I'm going to check for answers. So Shan says x equals 2, Ethan also says x equals 2, and Brian says x equals 2. Very good, very good. And let me walk you through it together. So we have two fractions here, right? And how do we get rid of fractions again? We have to multiply by them. So to get rid of x plus 2, multiply by x plus 2 on both sides. And then to get rid of x plus 1, just multiply by x plus 1 on both sides. And then you get something similar to this, okay? 3x plus 2 equals 4x plus 1. You just cross multiply, right? Just cross multiply. Okay? So you don't even have to think about it. Once you see equations like this in the future, you just have to think cross multiply, okay? And then now it looks more simpler, right? Looks like a very simple linear equation. So now you just unwrap the parentheses, do a distributive property, and then you can simplify to the next stage. And here we have it. And we just have to divide both sides by -1 now. Divide by -1. Then you get x equals 2. Did everybody get x equals 2? Okay. Very good. Okay, so you guys are getting a lot of correct answers. So congratulations. Let's move on. And now let's study another topic. Okay, we're solving advanced literal equations. And a literal equation is literally an equation made up of variables. Okay, it's just an equation made up of variables. So remember where I said where I taught you how to rearrange multivariable equations, right? Multivariable equations are literal equations, okay? So they're the same thing. But now we're solving more advanced ones, okay? So these are going to be like really easy. You're not going to solve them too fast, okay? So let me give an example. X equals, let's say x divided by y equals f x plus g x divided by f. Okay, let's say that's a literal equation. So let's see. It's made up of all variables, has an equal sign, so it's a literal equation, okay? And sometimes it can also contain numbers, right? Let's say f divided by 3 plus g divided by 3 equals x. Okay, that's also a literal equation. So sometimes it can contain numerals. Okay, and also when you get the solution of an literal equation, let's say x plus x equals y plus f. Okay, then you simplify. You get 2x equals x plus f. So you start off with only variables, but then once you simplify, you get these numerals, right? So there will probably be numerals. It won't always be all variables. Okay. So now, warm up exercise. Try to come up with a literal equation, for just try to come up with your own example, okay? Come up with your own example. Okay, Carney says, you need two variable equations to solve it, right? We actually want to solve what numeral x is for, right? Okay, so those are called systems of algebraic equations. So maybe next class or later, I'll teach you about systems of algebraic equations. But systems of algebraic equations, they are more advanced. So I might not be able to teach you about systems yet. But now we'll just work with some literal equations, okay? So please come up with your own examples of literal equations. Does anybody have any examples of literal equations? Okay, yes. Thomas, very, very creative one. Very good. Okay. Very good. Very good. So, very good examples. Now, I'm going to teach you how to solve them. Okay. So, to solve a literal equation, you just need to isolate the variable you're solving for, right? Let's say you solve for x. Solve for x. Okay, solve for x. And then let me come up with a simpler example to teach you how to solve these. Let's say x plus y equals f. Okay, that's very simple. If we want to solve for x, we need to isolate x, right? This is the same idea as the single variable equations. And we just move y to the side. Remember inverse operations. And we get x equals f minus y. Okay? You just have to isolate x. So when you only have one equation, you don't actually find the numeral. Okay? You just have to isolate x on one side and push all the other variables and numerals on the other side. Okay? So now, let's do some practice problems. Please solve for x on this one. Please solve for x, okay? So I'll give you a few moments to try and solve this problem, okay? And put your answer in the chat box. Okay. Yes, Carney, it is okay for you to eat something as long as you participate in the class. You can eat something. And Ray Shan says x equals f minus y. Then Jasmine says x equals y divided by f plus g plus 1. Okay. And then Thomas says 3x equals y minus f minus g. Ray Shan says x equals fx plus gx equals y minus x. And then Carney says 2x equals y divided by 5 plus f plus g. And then Rishan says x equals y divided by 2. Okay, so we have an assortment of answers over here. But I'm going to say that only one of them are correct. Or none of them. Okay. Let's do it now. Remember, these types of problems always have to factor first. You have to separate f and g from the x. And some of your answers now, some of them don't even include f and g, like x equals y divided by 2. So please double check your answer to see if it includes all the variables and try to make it reasonable, okay? So let's factor it out. So this is our simplified stage, okay? This is the next stage. Remember, all we have to do to get rid of f and g, just have to divide both sides by f and g, okay? But remember, there is another x right here. We have to divide this by f and g too. Okay? So then what you get is, okay, next stage, x plus x divided by f plus g equals y plus f, y divided by f plus g. And then you can cancel this thing out again, right? By multiplying it. But then you go back to here again, right? So when you try to get rid of this f plus g, you find that you can't actually separate it from the x, okay? So this is actually a mistake in the equation, okay? So if this x was not here, then you could simplify it, right? And I purposely wrote this equation wrong to see if you caught on that you have to divide f plus g on the other x too, right? You can't just divide f plus g on this x, right? You can't just divide that on the x and then cancel it out, right? You have to also, remember, divide it on all the terms, right? So just see if you caught that error. Anyways, let me change the equation now. Let's just do without the other x. Then it's very simple, right? You just get x equals y divided by f plus g. Okay? Okay. So, and Ray Shen says x equals y minus x divided by f plus g. And that is incorrect because you have to isolate the x. You can't have the x on the other side too. Okay? So, this should be the answer if this x wasn't included. Okay. So, second problem. We have solve for C, okay? So this one, solve for C. We have A equals 2 divided by B plus 3c. Okay? That is our question for number 2. A equals 2 over B plus 3c. Okay. Please put your answer in the chat box when you're done. Okay, and Carney says that this is like the square root of 2. Okay, that's actually a very interesting compare. Okay, few more moments, and then please put your answer in the chat box. Okay. Okay, Jasmine says no solution, non-solvable. Okay, are there any more answers? Okay, Thomas says 3c equals a minus 2 divided by b. Okay, Thomas, very, very good answer. But you have to get c by itself. Okay, Thomas, you're the closest one right now. Okay, so please elaborate on your answer and then you'll get it correct. Okay, so this one is actually a pretty hard one. Not because you might look at it and think it's pretty easy, but there's some things that you might miss. Okay, there are some things that you'll easily miss. Okay, you might not get this correct on first try. So please double check your answer, see if it's reasonable, and please double check all your stages to make sure they're correct. Okay, and that is why we solve these linear equations in stages. That way you can recheck it when you're done. Okay. Thomas says C equals A minus 2 divided by B, and then everything that is in parentheses and then divide by 3. Okay, Ray Shan has a similar answer. Jasmine says 3AB divided by 2. Okay. So we have a lot of answers here, and all of them are very, very close, okay? Especially Thomas and Rishan answer, okay? Those are very, very close answers. But we can simplify it even further, okay? So let me solve this. We have a fraction, right? So it's always important to get rid of the fraction. We have to cancel it out. So we have this fraction. We have divide by b, right? Let's just multiply every term by b, right? Multiply everything by b. So we get ab equals 2 plus 3cb, okay? And then you can do ab minus 2, right? You can get ab minus 2 equals 3cb. And then you want to separate this, right? And you might wonder, how do you separate it from 3 and b, right? So a trick is ab minus 2 equals, okay, so we just divide by 3b, right? We have to solve for c, we just divide by 3b, and we cancel out the 3 and the b, and we have to, of course, we have to divide it on both sides, okay? So the next stage should look similar to this. Okay, so that is our final answer. So does everybody understand where I'm coming from? Because this, yeah, when you're multiplying the fraction, okay? So I saw a lot of people, they said a minus 2 divided by 3b, right? So remember, we have to multiply a by b too. So that is what I meant by you might miss some of the things. Okay, so some of you miss some details. So so here is the answer. So does everybody understand why I get that answer? Yes or no? And Jasmine, Thomas, Rayshan, do you understand why you got it wrong? Okay. Yes, very good, very good. Okay, so that is the end of my class. Okay, so thank you for listening, and I also included this YouTube link in this last slide, and you might want to visit my channel for more additional videos, and also watch the videos that I did earlier, like last class, okay? And please like this video and subscribe. Okay.